Alright, hello everybody, welcome to our first video about percents. These notes are going to cover what is in section 10.1 of your book. It'll just be an overview, so you should still read the section. But our major goals are going to be to recognize percents as normalizing a whole, so somehow representing the whole in a consistent numerical fashion. 100% is the whole. And then also to just get familiar with everyday uses of percents and common mistakes that are made with percents. So the place we're going to start is with the phrase keep it 100, which comes from percents. Keep it 100%. And what does it mean? Answer that to yourself for a second. But then think, if somebody's keeping it 100, they're totally real. They're telling you everything. They're communicating it all. Communicate everything. So the 100 represents everything. Even if there aren't 100 individual objects in whatever you're talking about, 100 is what we mean by all. Okay, so to take that interpretation to a geometric level, let's look at these grids and let's write the percent of the grid that is covered by each pattern. So first things first is to talk about which pattern is what. Hatching means a bunch of lines that are right next to each other. There's also cross hatching, but we just have hatching. Dots are dots. Stars are stars. That's not a good star. Shading is like fully colored in, so different than hatching. And blank just means blank. It's going to be green on your screen, or it would be white if you downloaded the PDF. Alright, the next thing to do is to know how big the whole is. So let's work with the left grid first. And this left grid has 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. That's 9 by 1, 2, 3, 4, 5, 6, 7, 8 by 8. So there's 72 blocks total. So that's not 100, but that's what our whole is. Our whole is 72. And so when we go to calculate the percent covered by hatching, we have 5 out of 72. So we can write that fraction, and the way that calculating the percent will work is we convert it to a decimal. We convert the fraction representation of that number to a decimal, and then we convert the decimal to a percent. And so we just need a calculator to divide 5 by 72. None of those are calculators. Five divided by 72 is 0.0694. I'm going to use 4 decimal places for going forward. So we just need to remember 0.0694, because that's just usually enough decimal places for most things. So to write it as a percent, like these two numbers are the same in the sense that they represent the same quantity on a number line. But to write it as a percent, you move the decimal place over twice, which is the same thing as multiplying by 100. You have 6.94%. All right, moving on to the dots. The dots cover this diamond, and you see that diamond is a square too. But that square is not a 2 by 2 square. So we need to think of a way to figure out how many of the little tiny squares are covered by these dots. So if you break this square diamond into quarters, you see that there's 4 pieces, and we can look at this little triangle within the bigger triangle and rotate it to right here, and it would perfectly fill this spot. So you have your little dots here, and then you'd see, okay, that's 2. There are 2 squares covered by dots right there. And that would represent the number of dots that were in 1 quarter. So we have 2 times 4 is 8. So 8 total little squares are covered by dots. That's 8 out of 72. Oops. 8 out of 72. And we'll just go to our calculator. Oops. Point 1111111. If that surprises you a bit, note that 8 out of 72 can be written as 1 out of 9. And then maybe that's more familiar with you. To write that as a percent, you move the decimal place over twice. Right on. Move into stars. Stars are over here, and they are filling up a rectangle. And that rectangle is 5 by 3, which means there's 15 total squares covered by stars. 15 out of 72 equals, get your calculator handy, 15 out of 72, 2083 is the number we want to remember. Move on back, 0.2083 is 20.83%. Notice all our percent so far are numbers between 0 and 1. And that makes sense because all our decimals are numbers between, all our percents are numbers between 0 and 100. That makes sense because all our decimals are numbers between 0 and 1. And we wouldn't want our decimals to ever be more than 1 because that would be more than 100%. And you can't have more than 100% because 100% represents everything. All right, last one here, shading. Or last, that's not true, second last. So we have this trapezoid. And the area of a trapezoid formula is hard to remember. But instead you can use geometry here. This little triangle up here, again, if we rotated it over to here, it would perfectly fill that empty space. So what area is covered by the trapezoid is the same as the area covered by this rectangle that we just drew. And that rectangle is 2 by 8, so it covers 16 total. So this will be 16 out of 72. 16 out of 72, we notice, is twice 8 out of 72. So we can predict that this should be 0.222222, but we can check that in the calculator. Indeed. So that's the same as 22.22%. Great. Now to do the blank, we would need to count up how many squares are covered by all of this mass right here. And that is hard and annoying. But what we can recognize is that all the percentages need to add up to 100 because these 5 patterns cover they cover the whole grid. And since the whole grid is represented by 100% and we have 4 of the percents already calculated, the 5th one just needs to be whatever number will make all of the percents add up to 100. So the way we calculate that is we subtract all of the percents we have from 100. So first what we want to do, how can we write this right? 100% minus everything else. So we need to figure out the sum of 6.94, 11.11, and so on. Let's go back to our calculator. One thing that's nice about Desmos as a calculator, it keeps tracks of all these numbers, so we don't have to remember them. 111 plus 0.2083 plus 0.2222. 611. So this is 100% minus, let's get rid of the little 8's in the way, minus, and here's where you're like, if you write 0.611, it's going to be confusing because we have a percent and a proportion, and that is just not very fun to look at. So let's convert our proportion into a percent. So that's 61.1%. And that is 38.9. So 38.9% of the grid on the left is covered by blank space. So now let's move over to the right. And the right, so that's, same strategy. We need to figure out how many total squares there are, so we know what the whole is being represented by. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10 by 10 grid, so there's 100 blocks total. And what we'll find is when the total is already 100, calculating percents is super easy. The next thing to notice is that the way that I've drawn these pictures out is the amount of blocks covered by any particular pattern is the same. Right? There's still 5 blocks covered by hatching. If you look at the diamond, it's the same number of blocks that are covered by a diamond. So we don't really need to do any more geometry in that respect. So that means that the fraction we're going to consider to calculate the percent that is covered by hatching, its numerator is still 5, but it's the denominator that has changed. The number on the bottom of the fraction represents how many you have total. We have 100 total. If you divide 5 by 100, you get 0.05. If you multiply that by 100 to get the percent, you get 5%. So you see there's no trick here. It's just because we have 100 in total, the number of little blocks is also the percent. So likewise, 8 out of 100 is how many is the fraction that is of the whole that is covered by dots, and that's equal to 8%. 15 out of 100 is a 15%. And 16 out of 100 is 16%. So notice that all of these numbers are also smaller than their companion in the left grid. So 5 is less than 6.9, 8 is less than 11, 15 is less than 20. And that's because we covered the same number of squares, but the total number of squares was larger in the right grid. So you cover a smaller percentage of the entire shape. Now think if that's going to be true for the percent calculation, or the calculation for what percent is covered by blank. So we're talking about what percent of the whole is represented by this bit in yellow. And just by looking at it, it looks like there's a higher percentage that is covered in yellow on the grid on the right. And think about how we calculated the percent that was covered on the blank. We added up all of the percents we had, and then we subtracted them from 100. If we do the same thing, we add up all of these, well, we're adding up smaller numbers. So then when we subtract it from 100, we're going to be left with a larger number. So let's do that. We don't need a calculator to add these up because 5 plus 15 is 20, and 8 plus 16 is 24, and 20 and 24 is 44. So this one is going to be 100% minus 44%, which is equal to 56%. So yeah, as we thought, this number is actually bigger. 56% is bigger than 38.9. Cool. So this is a visual representation of percents being used to reflect part of the whole. And notice in both cases, all the percents add up to 100, but only in the grid on the right are there actually 100 blocks. So this is what we mean by normalizing. We somehow turned the number 72 into 100. So that now we can compare to different grids that don't have 72 blocks. And that is a useful feature of percents. Okay, thanks for watching.